Hello and welcome back to the SnekTek YouTube channel. In the previous video you saw me use the SnekTek Air relay and director to control this spot welder for batteries. With the temporary SnekTek Air setup, I wasn't able to control the current. This one I got from an Aliexpress listing that I have here. You can see it was $25. With the new control board, it has a few tricks up its sleeve. This control board features an SCR or thyristor, which is the same technology used in light dimmers. And the idea is that as the AC voltage wave passes through the board, it chops it to reduce the power. If it's at full power, it allows the full wave to go through. If it's at half power, it chops the wave halfway. We'll see that later on the oscilloscope. You can also see the white isolation marking, and this is where the high voltage and the low voltage are separated. The only thing that crosses over the isolation is the SCR signal right here. This board requires a power supply to operate, a separate low voltage power supply. It's very tempting to attach a switching DC supply, but they mention in the listing that you should only attach an alternating current transformer supply of 12 volts up here. And the reason is there's a circuit in here that synchronizes the wave from the mains so that it knows when to fire the SCR. If it didn't know when to fire the SCR, it wouldn't be able to chop the primary winding voltage in the proper spot. I will now power on. You will see how this user interface works. So you can see how there are two power settings, and those control the percentage power for each pulse. And below we see the time. Here the 90 pulse for 90 milliseconds. The 100 here indicates to wait 100 milliseconds between pulses, and the 90 here indicates to pulse for 90 milliseconds again. And these can be adjusted by clicking and then turning the encoder. To activate the welder, there's a switch input here. Now I'll show you how the SCR chops up the wave to limit the current. I've set the first pulse to 51% and the second pulse to 100%. The oscilloscope probe is connected to the output of the SCR. As I bridge the switch, we capture the waveform, and you can see how the first pulse is all chopped up, whereas the second pulse is a perfect sine wave. If we zoom in on the first pulse, you can see how it's chopping the pulse to reduce the amount of area under the curve. I've reduced the power to 20% on the first pulse, so we'll see what that looks like. You can see how the wave is very tiny. There's not much power coming there at all, whereas the second one is much stronger. Now let's look at the signal that's coming across this transformer to control the SCR, but from the digital side. And we see some lower voltage signals. I don't have any more battery to weld, but as a test I'm going to weld some of this nickel strip onto this. I put a simple switch on there, so it's time to test it out. Thanks for watching. If you like this video, please push the like button and subscribe. Bye.